thank you for joining us today. We have another amazing guest and a terrific show for you today. Today, we are really going to be focusing on the expansion and support of large in-space infrastructure. Welcome to the Tech and Space Leaders Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Anna Shaposhnik. She is the CEO and founder of ORBES. Welcome to the show, Anna.
Thank you so much, Lisa.
Absolutely. Thanks so much for making time to be here. Maybe we can start by having you give a little bit of background on yourself and ORBES.
Definitely. Well, ORBES is building robots to inspect and maintain large space infrastructure. My personal background comes from USC's Rocket Propulsion Laboratory. We're the team that launched the highest and fastest student-built rocket to space. I worked across teams in machining and videography and marketing the team, as well as I was part of Orbit Fab for 2.5 years. They are the satellite refueling company. I was there when we were 15 people in a small San Francisco garage, all the way to 50 people in Colorado, worked directly with the CEO and CDO, was able to be part of a lot of investment meetings, sales meetings, prepare all of the different marketing aspects like the website, PR, graphic design across the board. And that really gave me a flavor for what it takes to build an ambitious space company. And so ORBES was born with that same inspiration in mind. I saw firsthand the difficulty to maintain infrastructure in space. In Orbit Fab's case, it was to refuel spacecraft, but in our case, it's to actually maintain the physical structure of large infrastructure.
Wow. Okay, that is amazing. What really motivated you to found ORBES? And I guess what gap did you recognize in the space infrastructure industry?
Billions of dollars are being spent on large infrastructure right now. You can see Starship is enabling larger and bigger projects, for example, space data centers, space solar farms, private space stations, larger national security assets. But the challenge they have is that they don't have the astronauts on board to go outside, do spacewalks, physically maintain these structures. They will need robots, and we're the company to provide those robots.
Oh my gosh. What kind of inspired this, especially, I guess, looking at some of the history in the space industry?
Definitely. For me, a really important part and historical story I'm inspired by and learn lessons from is the Columbia disaster. I was born a year after that disaster, and the reason it happened is that a small piece of foam caused damage upon launch of the space shuttle. Once they were in orbit, there was really no way to assess how bad the damage was. It could have been just a blip, or it could have been a massive damage to the thermal protection system. NASA tried pointing spy satellites, they tried pointing ground telescopes. They just couldn't see in high enough resolution and detail what was going on. And so they were forced to take the risk and send them home. And unfortunately, 7 heroes died that day. That's a story that I heard talked about by astronaut Terry Virts in my sophomore year of college at USC. I heard about that. It was heartbreaking to me and interesting to me. How can we prevent this for future large structures? Again, right now is such a pivotal time in the space industry that we're accelerating really fast. We don't want another accident like this to happen. We need to prepare to have robots available on site to be able to maintain these structures and allow beautiful, amazing new types of large structures to exist. For example, space-based solar power, right? How do we get industrial level scale power 24/7 to anyone on Earth? These are things that can change the way we see each other on Earth, and it can change even peace on Earth, right? If everybody has available energy like that. So I think it's very meaningful to me that I'm able to build the maintenance backbone for these large structures.
Oh, wow. Okay, so how does this actually work? Are your robots on maneuverable spacecraft that then can maneuver and do operations up close and personal, obviously, with these structures?
Definitely. So for us, the focus is specifically on large infrastructure. You probably have heard that there's a lot of different servicing vehicles out there, companies like Turian Space, Rogue Space, Starfish Space. They have large 100-kilogram plus vehicles that carry enough propellant with them to be able to travel between different orbits and service constellations of smaller satellites. For us, that's not our focus. We specifically are building local kind of drone protection and maintenance drones for large structures. So we are 12U sized CubeSat would launch along with the large infrastructure, be able to deploy, perform a 10 to 20 meter standoff, capture images from any angle, and eventually also have the physical robot arms to be able to latch on and do physical maintenance tasks.
Oh my gosh, that is amazing. So how do you, I guess, what specific task do you see the Orbs robots accomplishing?
Definitely. There's several that come to mind as the most important and urgent to start with maintaining. I again look to historical examples. One of our mentors is astronaut Scott Parazynski. He performed one of the most daring repairs of an ISS solar panel. They had a tear, which later found out from man-made space debris, and they had to spend an entire day figuring out the root cause first, send him out to see what's going on, and then send him back out the next day to physically fix. He was hanging off the edge of the Canadarm with Kapton tape wrapped around his hands, stringing a little cuff link to bring these two solar panels back together. That's something that was definitely dangerous. It was, it took a lot of planning to do, and it was difficult to see from inside the spacecraft. And that's something a robot would be much better prepared to do. We particularly are focused on most common failures. So a solar panel doesn't deploy properly, or there's a tear, or there's micrometeorite damage that you can cover up with a patch. We're focused on physical maintenance and upgradability. For example, space data centers need to be able to put in new compute racks to stay relevant. Otherwise, they may not be competitive with space data centers here on Earth. We're also focused on, if, for example, there's thermal MLI on the outside of a spacecraft that's not in the right place or got dislodged, all kinds of different maintenance tasks like that.
Got it, got it. Okay, so where are you in the development process?
Definitely. We're blazing ahead. We got our first funding. We are fully funded for the ISS demonstration mission, planning for April of 2027 or early next year. We also have a partnership with Symphony Space, which is building uncrewed space stations. They will be our first flight for our ExoOrb satellite, which I just described, and that will be end of 27 or early 28. So again, we have two products. One is the external satellite called ExoOrb, and the other is our internal space station drone called Orb, which will be in the April flight.
Okay. So what will the demonstration flight do, or what tasks will it do aboard the ISS?
Yes, so the Orb robot is basically a 3D drone. It has 12 propellers, 4 per axis, so it works only inside the pressurized environment of space, but it is our technology step to validate our GNC and controls logic for localizing within the station, creating very smooth movements, being able to utilize robot arms to do tasks. So we have here a lay robot first prototype, which is one open source arm. We're building our own as well to leverage the unique aspects of moving around in zero gravity particularly. We also have a modular payload bay, so we can put a variety of different cinema quality cameras. One of the most valuable aspects of a space mission for the astronauts is being able to share it with the world and tell people what they did and move culture that way as an astronaut. And so for me personally, with a background in filmmaking as well, it was important to have the ability for them to put high quality cinema cameras in our robot too.
Right. Oh my God. Okay, so there's lots of engineering that goes into this. How is your team kind of approaching these engineering challenges, especially when you're talking about operating in space and doing things that are somewhat, maybe some of these things haven't ever been done before?
That's a great question. We're definitely blazing a lot of trails and improving robotics in space, but we also have a lot of amazing predecessors to thank, like AstroBee is another free-flying robot. AERCam was an external free flyer that could scout ahead for spacewalks. R5S7 is very inspirational to us for how they could reduce the cost of a satellite bus, to do inspection of a Falcon fairing. And so from all of these, we've improved on several aspects. One is how do you actually train these robots on Earth in microgravity conditions for a fraction of the cost? Typically, to train this, you would use an air-bearing table, which is like a flat frictionless surface. It's like a reverse air hockey table. So your robot glides along this glass surface, and you get 3 degrees of freedom, 1 rotation, 2 translation, that you can validate on Earth. What we've done is we've actually developed a proprietary 6 degree of freedom rig, which uses counterbalanced arms passively to get within a volume of several cubic feet the lifelike representation of near zero gravity in all 6 degrees of freedom. That helps a lot with improving the capabilities our robots have, both inside the station and outside as well.
Wow, amazing. So, what are the economic implications of this? I mean, obviously, to a certain extent, when you're talking about large constellations and small sats, a lot of those resources are somewhat disposable. But when you're talking about larger infrastructure in space, it's not so disposable, hopefully, right? So, what are the economics of this?
Exactly. Space services as a whole is a $300 billion market that includes everything from maintaining constellations to large structures. But I think the future is in those large structures, in particular because of what's enabled by Starship. Starship will dramatically lower the cost of launch from $3,000 per kilogram to around $100 per kilogram. That'll enable never before possible or things we've never thought of before. And those large structures, most of them will not be crewed, and most of them will be running autonomously. And I think that an autonomous future is actually a safer future. It's a future where astronauts, can go beyond LEO and GEO, and they can start living on the moon and Mars and do the far-out exploration we want them to do. While all of the industrial type of factory equipment, right, orbital data centers, orbital warehouses that host a variety of different tasks, can have these robot drones, maintain them, going around them, being able to move supplies back and forth. For example, I recently attended the Space Logistics Workshop in Los Angeles, and one of the key missing aspects in space right now is that local workforce to do things, right? Down on Earth, you have the foot soldiers that are unloading cargo, that are preparing the vehicles, that are receiving supplies and distributing them. But in space, you don't have that network yet, and what we want to do is enable these small, inexpensive vehicles to be able to go around and provide this kind of local network.
Ah, interesting. Okay, how is your system enabling the autonomous aspect?
Definitely. So in terms of some of the details of ExoOrb, we are using cold gas thrusters, nitrogen, as well as iodine thrusters. We're combining those two, so the cold gas thrusters can do all the close movements next to the vehicle, and the iodine thrusters can do some of the longer-term, slower movements, like going around the vehicle. Iodine, for example, we have to fire perpendicular to the structure because iodine can leave a film on the structure that could impede some optics and things like that. The way we're enabling autonomy is through having a human operator sometimes in the loop, but not for the full duration of the movement. There are other companies that are focused more on teleoperation, and we believe that's a little bit harder and less safe because a human operator will still experience some latency between the Earth and space. And you can have communication blackouts, you can completely lose access to the robot. If you don't have autonomy built in, you truly just don't have that safety fallback to trust that your system can go to a safe space or can perform its task that you asked it to do. So we're starting with pre-programmed modes or pre-programmed actions that we've validated and tested rigorously on Earth first.
Ah, interesting. So is there an AI or machine learning aspect that you'll roll in at some point as well?
Definitely. We're starting building up the complexity of the software step by step. For example, like for training the robot inside the station, we start out with fiducials, which are like April tag looking QR codes, right, that line the table, and we're able to do a perspective and point algorithm to know where those are and where the robot is relative to them. We're building up, right now, we're training a model to recognize specific landmarks inside the ISS. We want it to be robust for Orb to be able to go inside any different kind of station or environment and already know which landmarks are important, which landmarks are stationary, so that if it has at least 3 of them, it knows where it is in space. Same thing for outside. You need to, first of all, be able to see what you're approaching. So you need a combination of LiDAR and visual to be robust to darkness or shadowing in certain areas. And taking that all into account definitely requires AI and machine learning.
Okay, so talking about autonomy, the other end of it is, where do you see that division of labor between human and robot?
Yeah, that's the most exciting thing to invent, I think. What we really want astronauts to do less of is menial, like maintenance-style warehouse task. Right now, every 2 months, around 5.5 tons of cargo comes to the ISS. And if you're living in like a small apartment and you always get new stuff coming in, you're spending about 2 weeks each month just unpacking things, putting them in the right places, making sure everything's organized, and a lot of time and effort from personnel on the ground that also have to manage very complex, dashboards with, detailed lists of all the supplies and where they are. Right now, they've recently piloted in the last decade, like RFID and other techniques that make it slightly more autonomous. But really, you need warehouse workers in space. You need our robots with little arms to grab items, move them where they need to be able to do that quickly, be able to do that safely, and have the connection between the ground units and mission control and space to be able to plan ahead. So we're operating more like a Roomba, right? You pre-plan a Spotify playlist of tasks that the robot needs to do every day, and it performs those. Or you ask it specifically to go to a certain spot and do something, and it'll do that autonomously until you give it the next action to do.
Wow, fascinating. Okay. Are there technical or regulatory barriers that have, I guess, challenged getting this all off the ground for Orbs?
Yes, we will be encountering, all of the standard, FCC regulations, making sure that we're coordinating for, safe rendezvous proximity operations, and we're working with our lawyer partners for that.
Gotcha. Okay. How are you, I guess, collaborating with your partners and customers? You mentioned a couple of upcoming missions or demo missions. How does that work?
Yeah, definitely. Mary Walker, the CEO of Symphony Space, I think is doing an incredible job at opening a new kind of market. Her background is as a diplomat, and so she has access to knowledge of all the different space agencies around the world, what payloads they need to send. And so she's providing them a much more lower cost alternative to a traditional space station that's crewed by using autonomy to lower the cost. So we're very aligned on our interests. And our ExoOrb satellite will be able to first provide beautiful imagery, third-person point of view, making sure that their first demonstration is working well, making sure they can see any issues from that third-person point of view they wouldn't have otherwise. And in the future, also hosting us to be able to demonstrate our robot arms. Symphony's uncrewed station also has a large robot arm that'll literally use to capture payloads and attach them to the body of the uncrewed station. So we won't be doing that aspect, but there are some things like on the far out parts of the solar panels that we can help repair, or other demonstrations we can do.
Amazing. What is the, I guess, lifespan of these drone spacecraft?
Yes, so we are focused on building a Class C type mission, which in NASA lingo is one that's focused less on multi-string redundant systems inside the vehicle itself, and more focused on being like a drone approach. So you have a bunch of inexpensive spacecraft all available and all riding along with your structure. So we're not super worried about making it last very, very long. We're targeting 3 to 5 years for each one of them, and we'll be happy with that.
Okay. So going forward, what milestones will kind of mark that we're down this path and this is a reality?
Definitely. For us, something really important is to gain our first mission with the Space Force. We've been working hard negotiating on a possible mission with one of their large security assets to launch along with them, demonstrate that RPO capability and getting third-person imagery. For the Space Force in particular, they're interested in a flexible bus, moving away from their exquisite one-off missions and use it for a variety of purposes. So not only a third-person point of view, maintenance, but also perhaps a more offensive or other defensive capabilities. And so we're open to having a modular payload for them to use in any way they want. And other milestones I'm very looking forward to is moving along from the ISS mission to making our early first revenue from future private stations and the ISS mission. For example, we are interested in looking out for the astronauts that will be on board on the ISS coming after our April demonstration. It's available to lease out our robot to be able to capture imageries or use the robot arms for a demonstration of sorts. So we welcome any people in the community who would be interested in collaborating with us on this robot. It will be available. And for ExoOrb, really looking forward to getting those first snapshot images of Symphony Space's station in all its glory against the beautiful black of space.
Oh, fantastic, fantastic. Okay, so if someone wanted to learn more about Orbs or connect with you, what should they do?
Yeah, please go to our website or my LinkedIn. I post regularly about our journey, sharing the story, sharing our milestones. So https://orbes.space is our website, and we are orbs_space on X and other social media.
Oh, fantastic. Well, thank you so much for making time to be here today, Anna. It's been an inspiring and really informative interview.
Thank you so much, Lisa. It was a pleasure.
Absolutely. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.